Good morning, guys. All right, today we're going to talk a bit about Sahara. This was going to be a full-fledged session during the Boston Summit in which we were going to conduct a workshop on how to configure OpenStack Sahara in 1 hour and a half. Unfortunately, that one didn't happen. I'm hoping that we can have the chance to do it again in Sydney. So hopefully some of you guys will be there. All right, OpenStack Sahara. Before we start with the session, I would like to post a question, and that would be how many of you guys are actually running data analytics workloads in OpenStack at the moment? Don't be shy. Come on. Yep. All right, and how many of you guys are actually doing it in Sahara today? Only one. All right, cool. Yeah, this is actually a common trend. I was talking to Michael just now, and he posted the same question. So it's not unusual that there are quite a number of data analytics workloads running today in OpenStack, but most of the people is not using Sahara. I just added this slide, which I am borrowing from Heidi from OpenStack Foundation. She ran the session in the morning. And this one basically highlights the popularity of some of the new projects. And I don't know about you guys, but I think I already figured out the way to know which projects are the ones that are going to be picked up in the future. And basically, anything that is north to OOO should be doing fine. Anything south, not so good, huh? All right, that's the way we benchmark the good projects in OpenStack at the moment, the new ones. OK, a little bit of background in MapReduce. Some of you guys are already familiar with this, so perhaps just a bit of the basics. So MapReduce, there is a lot of information usually in the data lakes for the customers, and what they want to do is take all this data that is available and make some relevant information that hopefully will translate to benefits to the business, right? And the way they do it is they have this pool of input files, and they run a process called map in which they create keys, and they associate the keys to these particular files, and then after the mapping is done, they start the shuffling process. And the shuffling, basically what it does is arrange the keys. All the similar keys hopefully will go to the same worker, and then after all the workers get their respective mappies, we run what is called the reduce process, which basically will take a look at the process that you define. It could be Java or C or whatever of the languages that we use in MapReduce. And then after that, you will have some useful information based on all the data that was previously available. OK, that's in a nutshell. Now, Hadoop in OpenStack, why this one makes sense? So like you already know, the growth of the network is a lot faster in terms of speed as compared to the data drives. And we can see that we double speed on the network every 18 months, while on the data for these drives is about every 24 months. So the bottleneck is usually on the disk. So that actually makes sense to scale the Hadoop clusters horizontally. Today, there is still quite a wide adoption on bare metal for Hadoop. And the main problem that customers usually have is that when they want to scale, they have to scale all the components. So they have to scale both CPU and disk because that's associated with the bare metal machine, right? So this is what we call the main bottleneck that they have at the moment. They have a lot of spare resources that they are not really utilizing in the Hadoop cluster, and they should be a way to smarter segregate these. So the way that we do the decoupling is basically putting this into the cloud. Once we put the Hadoop cluster into the cloud, we are able to allocate CPU resources on one side, and then we can have the storage as a separate resource, and then we can leverage on this pool of storage from all the compute nodes, OK? So we have here 3 kinds of storage. Basically, we can leverage on Cinder, and we can use Cinder as the HDFS, which is the storage that we use for Hadoop to place all the data. On the other hand, we have our ephemeral storage, the one that we use to boot the VMs, OK, unless we are using Cinder boot. And this ephemeral storage is pretty much used by the computes to boot the binaries and basically run the process from there. And finally, we can leverage on Swift object storage. And using Swift object, we can pretty much place in that storage all the input files, the outputs, and also the jobs that you define. Later, I will show you that in a brief demo that we have. All right, the key takeaways that we have for today is, I think that the main one is the huge amount of memory that we have in the servers today. And for those of you familiar with Hadoop, Hadoop leverages quite a lot on disk. So we have another component that we call Spark, which is pretty much in-memory data analytics. So this is kind of the two words that we have in Hadoop. Some customers are advocating for Spark. They prefer to have everything on memory. And then some others prefer to use Hadoop, which is more for batch processing. All right, of course, nowadays Spark can also leverage on HDFS to put some of the output files also on disk storage. And finally, another key question that we have from most of the customers is, all right, this is good for upstream Hadoop, but how about enterprise distributions? So 3 main ones in the market, like we know, we have Cloudera, we also have Hortonworks, and we have MapR. So you will be happy to know that all these distributions, actually, they are available for OpenStack. And from the link that we have in this slide, Mirantis is basically the key contributor for Sahara. We can actually download all the images for glance for these main distributions. All right, let me jump into the demo. We have a quick demo with Helion OpenStack. Okay, I am still using the Newton release, and it is actually possible to deploy Sahara on Helion OpenStack. And perhaps I should address the elephant in the room, right? Some people may be wondering how come Helion OpenStack is still with HPE. You may have heard the rumors that we actually sold it to SUSE. So it's right, it's belonging to SUSE at the moment. So what we are doing is we OEM from SUSE, and we still provide integration services for Helion OpenStack and back-to-back support with SUSE. Okay, so all this integration, if you want to integrate today with Sahara and you want to run data analytic workloads, is actually possible. We just released our Okata release 2 weeks back during the summit, and we are pretty much running this version today with data analytics. Okay, what I will do at the moment, I already have a cluster running for MapR, so I'm going to show you quickly how to access the MapR console. But before doing that, let me launch a cluster based on upstream Sahara, which is going to take about 4 to 5 minutes. So let me start that now so that we don't waste time. I'm going to make it public, and let's just launch it. All right, while this one is going, let me just quickly jump into the MapR cluster so that we can take a look how this one looks like. How many of you guys are familiar with MapR, for those of you running data analytics workloads to there? I think that Cloudera or perhaps Hortonworks is the most popular in the region, maybe? Okay, so this is the MapR console. What we can do, everything is linked to Sahara, so it's quite clever in that sense. And later I will show you all the plugins that are available. But basically from this link, we can just access the control system, and the password is randomly generated every time that we spawn a new cluster. Okay. I'm going to log in with user MapR. And from here, we can see the MapR console, all right? So this one is actually what is provided by the MapR distribution. This is not enterprise MapR. Obviously, if you want to run the enterprise release, you will need to buy the subscription from them, okay? So this is what we call the community release. Okay, let's go back now to the Sahara project that we have here. And from here, what I can show you is that every time that we want to create a new cluster, we need to start by defining the images that we're going to provide for the cluster, right? In this case, I have upstream Sahara, and we also have MapR, which is the one that I showed you just now. These images are nothing more than glance images. So if we take a look at the glance portion in our horizon, we should be able to see from here that we actually have the images for Sahara, MapR, and also from upstream Sahara. Okay, so nothing new there. Let's go back to data processing. After we have uploaded the images into our cloud, what we need to do is create what we call the node group template. Okay, and these node groups, we basically give it a name. It could be a worker, and this worker we are going to define all the process that is going to run. Okay, and we also have the definitions for the master. And again, we give all the process that the master is going to run. So once these have the definitions in place, we can proceed to create what we call the cluster template. And in this template, we're going to tell them, okay, each of the clusters that I'm going to spawn in my cloud, I want to have this many masters and this many workers. So for instance, the one that I'm launching just now, it has 2 workers and only 1 master for our upstream Hadoop. And finally, you just go and create your cluster. Let's talk a bit about the plugins. Today, this is what is available. If you go to the Mirantis website that I showed you a few minutes back, you should be able to get from there vanilla upstream. Okay, you can get Apache Spark, and this one is actually coming from CDH, which is Cloudera. You could get also the full-fledged Cloudera product is available. HDP, this one is actually Hortonworks, available as well. Apache Storm, this is pretty much from upstream. And then we have MapR. All right, so these are the key plugins that we have. So every time that we spawn an image, a cluster like the one that I launched just now, is going to leverage on heat, and also is going to call these plugins in order to configure the cluster. And finally, let me give you a brief introduction about the jobs. All the jobs that we create, either we can program them using Java or C or Ruby or any other language that is available from MapReduce, we can actually upload the definitions here, okay? And if you realize from here, in this URL, I am actually uploading this in Swift, okay? So these jobs are actually stored in Swift. We can take a look at the data source, and I can actually create the definitions here on where we're going to bring our input files, all these data files that we want to run MapReduce jobs on, they are going to come from Swift as well. And finally, the output is going to be collocated in Swift. And then after that, we're going to define our job templates. From here, we're going to call which one is the binary that we want to use and where we're going to drag our input files. Okay? And quickly taking a look into the object store, we should be able to see from here that I have all these definitions. Okay? My data is coming from this container. I have the inputs here. The job binaries are actually allocated here. And these are my OpenStack keys, okay, which is not related to Sahara. All right, let me go back to the data processing project, and hopefully my cluster is already up and running. Yes, green status means we have a healthy cluster. I'm using 1 master and 2 workers. So what I will do is, let me just quickly trigger a job. So again, to trigger a job, you don't need to be that familiar with Java in this particular case, because in Sahara we provide all the APIs for you to launch the jobs. So as long as you have the binaries in place and you have your input files that you want to basically run the MapReduce on them, then you should be able to trigger everything using APIs. So we can either use the OpenStack Data Processing API, or we can do everything from Horizon, which is the one that I am going to use now. Let's go to jobs. We can go to templates. And what I will do is I'm going to launch this template into an existing cluster. We're taking the inputs from this Swift container, and I'm going to place it here. I'm going to make it public. We don't need to put anything into the configuration or the interface arguments file, okay? At the moment that we launch this process, it's going to take about 1 or 2 minutes to run. So if I jump back into the Swift container, we should be able to see that there is an output file already being generated, hopefully. Right, let's give it a bit more time. Okay, in the meantime, while this one is running, let me just show you a few more things. So obviously, in Sahara, we are leveraging in all the projects. We have Swift. We leverage in Nova, obviously. If we take a look at the instances, we should be able to see that our master and both the workers, the definitions are actually here. Okay, it's pretty much just leveraging in Nova, sitting on KVM. And finally, the network definition has to be in place before we actually start the cluster. So it's a pretty simple topology. Only the external network, we have the Hadoop network, and everything is routed through OVS. Okay. We are leveraging on heat, but from your actual user, you won't be able to see any stack. Okay, the stack is actually hidden from the user. Everything is managed by Sahara, so you don't have access to the heat stack directly. Obviously, when I destroy the cluster, the stack is destroyed as well. Right, let me go back to the job. Let's see how this one is going. It's still running. I think that we just completed the job. So finally, if we jump back to the Swift container, which holds the data container, we should be able to see that the output file is available, all right? We have success status. It will report you whether it's success or fail on the container itself, and then we have here the data file giving you the results. Let's quickly jump again into the vanilla cluster that we just created, and from there we should be able to see from Yarn the job status. We can actually see it from job history or from Yarn. Whatever way that you choose is fine. So finally, if we jump into this one, from here we should be able to see a summary. All right? So we have a job that was mapped into 2 different workers, and then it succeeded. It doesn't say the time. Yeah, I believe it says the time. It ran for about 2 minutes before actually giving the results. And this is pretty much the way that we run OpenStack Sahara for data analytics. All right, guys, I think that's all I wanted to show for today. If you have any questions, I think that we still have about 8 minutes to go. Thank you so much.